Okay, so today we're going to graph quadratics and we're going to start in standard form. We're going to take a look at our first example. We have f of x equals 2x squared plus 4x plus 3. Alright, so like in the last video, I stated that there are a few things that we can determine without actually graphing yet. So up, down, we can determine if our parabola is going to open up or if it's going to open down by looking at my value of a. So I'm just going to write on the side what a is, what b is, and what c is just to remind us. So we know a is equal to 2, b is equal to 4, and my c is equal to 3. So remember, if my a value, which is 2, is positive, then my parabola opens up. If it's negative, it opens down. So my a is positive 2, so my parabola is going to open up. So if it opens up, remember our parabola is going to look like this when we draw it. That means it has a minimum. Okay, at vertex. Our vertex, well, remember it has to be a coordinate. And to find the x, we find opposite of b over 2 times a. And then we're going to plug in to find our y. So my b is 4, so the opposite of positive 4 is negative 4. So I'm just going to draw the work on the bottom. So I have negative 4 over 2 times a. Well, my a is 2. So we simplify that. So negative 4 over positive 4, which is negative 1. So that gives me the x of my vertex. So the x of my vertex is negative 1. Now let's find the y. So I'm going to plug in negative 1 every time I have an x in my function. So we have y equals 2 times negative 1 squared plus 4. Well, I have another x here, so I have to replace the negative 1 here as well. Plus 3. So we have y equals negative 1 squared is going to be positive 1. So I have 2 times 1. 4 times negative 1 is going to give me negative 4. Plus 3. Let's keep going. 2 times 1 is just 2. And now we're going to add left to right. So 2 minus 4 is negative 2 plus 3. So y is positive 1. So here, my vertex is negative 1, positive 1. So remember, I want to write my vertex in the middle of my table. So I have negative 1, positive 1. Then we're going to pick two numbers that are less than the x of my vertex. So one number that's less than negative 1 is negative 2. The next number less than negative 2 is negative 3. And then we're going to pick two numbers that are greater than negative 1. So negative 1 is 0, and then the next number is positive 1. So we don't always have 0, 0 in the middle of our table. It's going to vary depending on what our vertex is. Okay, so now we're going to plug in 0 and 1 to find out what our y values are here. So I have y equals 2 times 0 squared plus 4 times 0 plus 3. So look what happens when we plug in a 0. Well, 0 squared is 0. 0 times 2 is going to give me 0, so that cancels out. 4 times 0 is 0, that goes away. All that's left is 3. So when our x is 0, the a term and b term goes away, and we're just left with our c. So we have 3 there, and now we're going to find out what my y is when x is 1. So we have y equals, well, 1 squared is just 1. 1 times 2 is 2. 4 plus 3. And we're going to simplify. So y equals 2 plus 4 is 6. 6 plus 3 is 9. Right, so y is 9. So I'm not even going to plug in the negative 2 and negative 3 because I picked two numbers that were below negative 1 and the two numbers that were higher than negative 1, and they're the same distance from negative 1. Then these are going to be the same. Okay, so now we're going to graph. So my vertex is -1, +1, so my vertex is right here. And then my next point is 0, +3, 2, 3. And then -2, +3. And then we have when x is 1, y is 9. And then when x is -3, y is 9. Okay, so then we're going to draw through our parabola, curving at the bottom, and add your arrows at the top. And now we want to draw our axis of symmetry. So remember, our axis of symmetry has to be written as x equals, it's going to be a line, and it's x equals whatever the x of my vertex is. So the x of my vertex is -1, so x equals -1. So we're going to draw a dashed line straight through our vertex. Now there is one more point that I want you guys to add on to here. We're going to look for our y-intercept. Now our y-intercept is the point where our graph crosses the y-axis. So we can see that point is right here. So our y-intercept is a coordinate. Well, that coordinate happens to be here. When my x is 0, well, my y is 3. So 0, 3 is our y-intercept. Okay, so let's look at example 2. We have f of x equals -x² plus 2x minus 2. So we're going to start by labeling our a, our b, and our c. So a is -1, b is +2, and c is -2. Then we're going to determine if our parabola opens up or if it opens down. Remember, up it's a positive, down it's a -a. So my a value is negative, so we know our parabola is going to open down, which should help you to double check when you're graphing. That's also going to tell me if I have a maximum or a minimum. Well, if my parabola opens down, that means it's going to look like this, and I'm going to have a maximum. Alright, so now let's look at the vertex. So remember, my x of my vertex is opposite of b over 2a. So we have the opposite of b, which is 2. Opposite of +2 is -2 over 2 times my a, which is -1. So we get -2 over -2, which -2 over -2 is just going to give me +1. So the x of my vertex is +1. So now we need to determine the y. So I'm going to take my 1 and I'm going to plug it into every time I see an x into my original function. So I have -x, which is just 1 squared, plus 2 times x, which is 1, minus 2. So we're going to simplify this. So 1 squared is just 1. There's a negative. This negative's on the outside. It's not on the inside with the inside the parentheses with that 1. It's on the outside. So 1 squared is 1. So I have a -1 plus 2 times 1, which is 2, minus 2. So -1 plus 2 is going to give me 1. And then minus 2 is going to give me a -1. So my vertex here is +1, -1. And then we're going to put that in the middle of our table. And so let's pick our two numbers less than 1 and greater than 1. So the next number less than 1 is going to be 0. And then the next number from that is -1. And then two numbers greater than 1 are 2 and then 3. And I'm just going to take the positive numbers and then plug them into our function to find out what my y value is. So we have -1. X, instead of x, I'm replacing that with 2. So plus 2 again, instead of x, I'm also replacing it with 2. And we're going to solve. So I have negative 1 times, well, 2 squared is 4, plus 4 minus 3. So we have negative 4 plus 4 minus 3. So when my x is 2, my y is negative 3. So we're going to do the same thing when x is 3 now. So I have negative 1 times 3 squared plus 2 times 3 minus 3. So negative 1 times 3 squared is 9, plus 2 times 3 is 6, minus 3. So we have negative 9 plus 6 minus 3. Negative 9 plus 6 is going to give me negative 3 minus 3. So we get negative 6. So when my y is 3, my y is negative 6. And remember, these are going to be the same. So I have negative 3 here. That means I have negative 3 here. If I have negative 6 here, that means I have negative 6 here. So it should be like a pattern almost. All right, so we're going to graph the vertex first. So I have positive 1, negative 1 is my vertex. Then my next point, when my x is 2, my y is negative 3. When my x is 0, it is also negative 3. Okay, then when my x is 3, my y is negative 6. I actually don't have any more space, so it's kind of about here. Same thing with the 5, it's kind of about here. And then we're going to draw our parabola through. It doesn't have to be perfect, just like that one. So it opens down and looks just like that. All right, so we need to find the axis of symmetry. Well, my axis of symmetry is always x equals the x of my vertex. Well, the x of my vertex is positive 1. So we're going to draw a dashed line right through our vertex, and that's our axis of symmetry. And lastly, I want you to just tell me the y-intercept. The y-intercept is the point where my graph crosses my y-axis. Well, it crosses right here. We already figured that point out. It's 0, negative 3. So we're just going to write the coordinate 0, negative 3. That's it.